This is a production of Cornell University.
All right. Here is a table that's also from your book, okay? And there's sort of three things that you want to look at here. If we're thinking about soil erosion, what are some of the things that you want to think about? Well, first off, you might actually want to think about the size of the river, okay? If we're talking about water erosion, you really want to have an understanding of the size of the watershed. Now, some of these watersheds are so large that they go through multiple climatic regions, okay? But if we're just looking at the size, you know, we have, these are the top 10 and across the, these are the top 9 watersheds of the world, okay? So first thing is to take a look at the size. The second thing to think about is how much sediment is coming out. I mean, if we're trying to quantify how much erosion's happening, basically that's sediment coming out the tail end, right? Okay, well, let's take a look at the amount of sediment that's coming out of these watersheds. The Yangtze, I can't pronounce that quite right. We're looking at 1,600 million megagrams. That's the amount of load that's coming out. Versus the Nile, we're looking at 111. Okay, now that's the total load for that watershed. But not all of these rivers are the same size. So we also have to think about how much sediment is coming off of per area basis. And that's what you see over here. This is basically megagrams per hectare. The big one is actually not the one that's giving out the largest amount per acre or per hectare. Okay? We know down here, the Kosi, fairly large in India and Nepal. If it's in India and Nepal, we're certainly looking at high elevations or steep slopes at the top end of at the headwaters, okay, going into flatter landscape when we get down into India, okay? What kind of load are we looking at? Huge load compared to something like the Ganges and the Yangtze. Okay, look at those numbers. Way down here, the Nile, pretty small. The Amazon, fairly small too, even though the Amazon is really, really large. Well, looking at these three pieces of information, what kind of take-home messages can you think of? Why am I seeing these kinds of numbers for these rivers? Kosi, why do I see such a huge number? Where is its headwaters? It's in the mountains. It's got huge steeps. There's a lot of force of energy going through there. Okay? On the other hand, the largest in the world, what's going on there? It's not like there's not a lot coming out. But what's going on here? Vegetation, flatter landscapes. You know, there's a lot of stuff that's basically best management practice. We're not doing it. That's lowering this number while raising this number. Now, a lot of this, you look at some of these guys in here and some of these guys in here. This is not this one. These guys in here, this is human management. But this one versus this one, a lot of this versus this has to do just with the nature of the landscape that it's going through. Now, these numbers in the Amazon are certainly going up because of deforestation. The Kosi, on the other hand, there's not a lot we're doing there. Systems such as a wheat fallow system or something like that, and we'll just talk about the United States here. If this number or these types of numbers have to do a lot with the vegetation that's on the landscape, why do we in fact clear the soils for periods of time? Is that in essence what you're saying? Okay. There's a lot of different reasons why we do that. But often when we have those wheat fallow systems, and if it's a good management system, they'll take into account what the rain system will be, okay, what the climate's going to be and how that water is going to be delivered into the system. Now, part of what they will also do, now some of this is just bad management. They shouldn't be doing it. They should be keeping cover crops on. But part of the management scheme is, in fact, in other parts of the world, is in fact to have bare soil so that you can, in fact, harvest your water. there are a number of systems, and I do not know why this is not working. Okay, there's a number of systems. We're going to go off track here. My computer's not working anyway. There's a number of systems where we, in fact, do create bare soil systems so that we can harvest the water. Okay, has less to do with erosion and more to do with water harvesting. Okay, there's a number in North Africa is a really good example of some of these. There's check dam systems, and there's can't remember the name of the system, but there's basically if you imagine I have a hill, okay, and you're looking down at the hill, but imagine that I have a hill, and you're basically getting rid of all the vegetation on this hill, okay, and you're basically planting down here. The thought is twofold. If I get rid of all the vegetation up here, I'm going to have more flow this way, and I'm also going to have sedimentation coming down here. So I'm going to collect all of this down here, and this is where my crop is going to be. Does that make sense? Now, that is encouraging erosion, but you're trying to trap that erosion in another location. Does that make sense? Okay. Now, there are other systems where you're basically looking at stream systems. Okay, so imagine this is a stream coming down. Okay, what people will do is they'll build a series of check dams in here. Now, they're taking advantage of this basically being an irrigation system for them. They'll put a check dam in here, they'll collect the sediment, they'll grow their plants in here, they'll put another check dam in here, grow their sediment. Now, this is going to be going down a gully, pretty large gully, and then they put a dam in, and they basically create a water harvesting system where they are in fact stalling erosion, but they're also using that erosion to fill in their raised bed, for lack of a better word. Does that make sense? Now, around here, we're not trying to do this type of engineered system. Around here, we'll just basically leave the field bare in the wintertime or something like that. They're making that decision from an economic sense, saying, okay, I'm going to leave the soil bare for this year. I'll put my crops in quickly. A lot of people are changing that design. They're putting in more cover crops and stuff like that. Okay, any other questions on that? Does that make sense? Go.
One of the responses I got when talking to people about cover crops is, this was in West Africa, they didn't want to keep cover crops on it because they saw it as dirty and that it was a place for snakes to live.
Yeah, you get a lot of that when you start talking about it. So the question is, there's a lot of cultural history with some of these practices. You certainly see it with sort of cane operations where they have the snakes and the rats in the cane. But in this country, it wasn't too long ago that people like to they'd go out there and plow it to death, because they like to have that nice smooth surface. And there is actually good reasons why you want that smooth surface, because you want to have good seed contact for germination and stuff like that. You're prepping your seed bed. But you don't need to go quite to that extreme. Now, you're talking about some cultural aspects where people, it looks dirty if I don't clean the stubble off. And there are parts of the world where the stubble is a big source of feed or fodder or fuel for a lot of people, a lot of animals. Okay? But those are sort of cultural things. And there may, in fact, have been a reason why they did that. But yeah, so the sort of the cane operations, why they burn cane and stuff like that. When you get into sugarcane or something like that, there's a lot of rats that live amongst the cane, which means that the snake population grows, and to harvest it, you run into these issues with snakes because this is sort of mostly mechanical harvesting. The cutters don't want to go in the fields because there's snakes in there. And so often you'll go into the burning operations and stuff like that where they'll literally burn out everything and they come in and harvest. These are just different strategies to deal with different types of field crop operations. Okay? And
This has been a production of Cornell University, on the web at cornell.edu.